Assalamualaikum warahmatullahi wabarakatuh. My name is NAIM BADROLNIZAM and my matrix number is B11 2410 297. And today I will be presenting our PBL group project titled as Traffic Light Control System with Pedestrian Button. So this system is developed using MC68000 assembly language and is fully simulated by EZ68K platform. Our goal in this project is to replicate the basic operation of a real-world traffic intersection, including traffic light control for vehicle and a pedestrian crossing system activated by push button. So let me now explain how we set up the hardware simulation in our code. We use two memory map address. The output port is assigned to $00 E00010, and for the input port we assign it to $00 E00012. So these addresses can be found by clicking the assemble source button, execute, and then at this view section click hardware. So for the output we use this address, which is these LEDs, and for the input we use 00E00012 address for the button, pedestrian button. For the output, each light is connected to a specific bit. So for the green light for car is assigned at bit 0, which is this LED, and for yellow light is at bit 1, bit 2 for red light, bit 4 for pedestrian green light, and bit 5 for pedestrian red light, and this bit 0 button is for pedestrian button. So the logic of the program starts with the main loop. At the beginning of each cycle, the program checks the input port to detect if the pedestrian button has been pressed. If the button is not pressed, the program continues with the normal traffic light cycle. However, if the button is detected as pressed, the system diverts to a special pedestrian sequence before continuing with normal operation. So for the normal traffic light cycle, the car green light is turned on while the pedestrian light remains red. After a few seconds, the car yellow light is turned on, still with the pedestrian light still red. Then the car red light is activated, and again the pedestrian light remains red. This simulates a normal light cycle where cars move, slow down and stop, while pedestrians are not allowed to cross unless a button is pressed. If a pedestrian button has been pressed, the system enters a separate pedestrian crossing sequence. In this sequence, the car red light is turned on while the pedestrian green light turned on, allowing pedestrians to safely cross the road. After a few seconds, the pedestrian green light blinks 3 times, signaling that the crossing time is about to end. Following that, the pedestrian light is turned on again along with the car red light to clear the intersection. The system then resumes with the car green and yellow phase to continue looping as normal. So let me show you the simulation. So we can start the system by clicking the auto trace button. So for the first sequence, which is normal traffic light cycle, the green light will turn on first, and after a few seconds the yellow light turn on and green will be turned off. Then after a few seconds yellow turn off and red will be turned on, and this cycle will be looped until a person press a pedestrian button. So when the button is being pressed, the cycle continues to until the red light is turned on, and then the system will be checked the button has been pressed or not. If the button is being pressed, the red light will be stay and the pedestrian light will be turned green for pedestrian to cross the road. After a few seconds, the pedestrian green will be blinking 3 times before turning the red, and there will be a small delay before the red light turn into green, and then the cycle continue until a person push the button again. So all the timing in this program is managed using delay subroutine. We use decrement loop with different loop count to simulate a different duration. For example, we have separate delay routine for long duration like green light and red light, and shorter delays for yellow light and blinking pedestrian signal. Since EZ68K does not use real hardware timers, this delay loop serves as a simple way to control how long each light stays on. And that's all from me. Thank you for listening to my presentation.